All right, what's up, guys? Today we're just going to be learning about what molar mass is and how to calculate it when we get to more complex molecules. To start off with, what the molar mass actually is simply the mass in grams of 1 mole of a substance in general, and we'll find this molar mass value on the periodic table. So every element within the periodic table has a molar mass associated with it. You'll also hear the word atomic mass thrown for it. Both of those values are the same thing, just different units. And the units for molar mass are actually going to be in grams per mole. And a lot of the ways that we will be writing the molar mass are going to be, let's say we're talking about substance X, we'll be referring it to grams of substance X over 1 mole of whatever your substance is. So this is how we're going to be rewriting a lot of these. Um, so for the very first one, we have aluminum. Um, Aluminum is just simply by itself, is just one atom of aluminum. So in order to find the molar mass of it, we just go to the periodic table and locate it right there. So we see that the molar mass of aluminum is that bottom number, that 26.982. We can kind of round that off over to 27.0 as the molar mass of aluminum. And that's just for one atom of aluminum, we can say. And remember, the units for it are going to be in grams per mole. And I said that we would be rewriting a lot of these molar masses into this section right here or in this format, so let's do that. So you're going to keep grams up top, so it would be 27.0 grams of aluminum over 1 mole of aluminum. So what both of these things are essentially saying are, for every 27 grams of aluminum that you have 1 mole of that. So that's for a pretty simple molecule that's just by itself. If you were given something like O2, which, if you notice, is comprised of not just one atom, it's comprised of two oxygen atoms. So you have to take into account the mass of two oxygen atoms when you're calculating the molar mass of O2. You go by the same procedure. You want to find the molar mass of oxygen just by itself. So you locate it on the periodic table, and there it is. It's that 15.999. We're just going to say 16.0. So oxygen's molar mass, or the molar mass of one oxygen atom, you can say, would be 15.999, or just 16.0 is what we'll say. So oxygen has a molar mass of just 16.0 grams per mole, is always our units for it. But we weren't asked for the molar mass of O by itself, we were asked for O2. In order to determine that, you just multiply the molar mass by how many atoms of it that you have. So in our case, we're just going to take the number of atoms of oxygen that we have, it's 2, and then multiply it by the molar mass. So it'd be 2 times 16.0. When you plug that into the calculator, you'll get 2 times 16. Oops, my mistake. And your molar mass will be 32.0 grams per mole. And so this is the molar mass of O2. If you wanted to rewrite it in the format that I have, you just keep grams up top, so it'd be 32.0 grams of specifically O2 over 1 mole of O2. And so what both of these are saying is that for every 32 grams of O2 oxygen gas that you have 1 mole of oxygen. This one's slightly more complex, so now we have aluminum oxide. So aluminum oxide is comprised of 2 aluminum atoms. That's what that 2 under aluminum stands for. And you have 3 oxygen atoms. So we're going to go by the same exact procedure. We're going to just want to determine the molar mass of one atom of each of them. So we're going to look for aluminum, and we're going to look for oxygen. So we locate aluminum. The molar mass of one aluminum atom, we could say, is that number at the bottom, that 26.982. Again, we'll just write down 27.0, and the units are grams per mole. And then for one oxygen atom, same exact thing as last example. It's at 15.99 under oxygen. We're going to say that's 16.0. And again, grams per mole. Now, these would be the correct numbers if we were talking about one of each atom. However, we have 2 aluminum atoms and 3 oxygen atoms. So you have to calculate the mass of 2 atoms of aluminum and add up the 3 atoms of oxygen. So first we'll do aluminum. You just do 2 times aluminum's molar mass, which is just 27.0, plus the mass of our oxygen atoms. So you have 3 here, and you multiply that by the molar mass of oxygen, which is 16.0. And so when you add up all those numbers, you'll do 2 times 27 plus 3 times 16, and your molar mass will be 102 grams per mole. Now this is the amount of grams necessary for aluminum oxide to get 1 mole of aluminum oxide. So if we wanted to rewrite it in the other format, you'd keep the mass at the top. So you have 102 grams of aluminum oxide, Al2O3, per 1 mole of aluminum oxide. So if you have 1 mole of aluminum oxide, this is the mass you should end up having. And so the last example that we have, probably the more complex one of them all, we have calcium nitrate. Now calcium has a polyatomic ion within it, so it's a little bit more complex, but not too much. First, we want to break down how many of each atom that we have. So we can see that we have 1 calcium atom, and we have 2 nitrate atoms. We are going to split it apart into nitrogens and oxygens. And so the way that you do that is you take whatever subscript is below each of these elements. So in the case of nitrogen, you have a 1 under it. In the case of oxygen, you have a 3. And then you multiply it by whatever subscript is on the outside of the parentheses. So here it'd just be 1 times 2. So you have 2 nitrogen atoms. And for oxygen, you have 3 times 2. So that'd be 6 oxygen atoms. Remember that parentheses, you're encasing nitrate in the parentheses. So that's saying you have 2 of only nitrate. Calcium just has that invisible 1 under it. So you have to find the molar mass of each one separately. So for calcium, for nitrogen, and for oxygen. So if we go to calcium, you'll see that it's 40.078. We'll just round that to 40.1 grams per mole. For nitrogen, it'll be 14.007. We'll just do 14.0 grams per mole. And for oxygen, again, 15.999 or just 16.0 grams per mole. Now we can assume that these are the values for 1 atom of calcium, 1 atom of nitrogen, and 1 atom of oxygen. So we have to use these to calculate the total molar mass of calcium nitrate. So let's do calcium first. So it'd be 1 times calcium's molar mass, which is 40.1, plus nitrogen is up next. So you have 2 of those atoms. So you'll multiply that by its molar mass, which is 14.0, and then plus oxygen. So you have 6 oxygen atoms times its molar mass, which is 16.0. And so when you plug all of that into the calculator, you'll get 1 times 40.1, which is just 40.1. And then you'd add up 2 times 14, close parentheses, plus now the value of oxygen, which is going to be 6 times 16, giving you a total molar mass of 164.1 grams per mole. Now, if you wanted to rewrite this in the format that I've been writing it, you would just keep the mass up top, so it'd be 164.1 grams of calcium nitrate, CaNO32, per 1 mole of calcium nitrate, so CaNO32. And so that is how you would calculate the molar mass of any element. It would just depend, or molecule or element, it just depends on what you've been given.